Hello, my dear friends. In the last video, I have talked about the group and its definition. Yes, it is a function star from G cross G to G, basically, which follows certain set of operations and properties. Then it will form a group. It is just a set, right? So I have given you some examples, right, of the group R plus C plus R star dot C star dot, right? So these are groups. But I have given the idea of abelian groups to all of you. So let's discuss what are abelian groups. Although I have given the idea. A group G a group is called abelian group or commutative group if AOB is BOA. This if you take any two elements, right, you take a tuple A comma B and you map it to a same element like B comma A from G cross G to G. The value will go in G. Then you say that if this follows, then G's will be an abelian group. Now examples of commutative group are, what are examples? Z plus, you just take any two members, A plus B is B plus A, Q plus may be and R plus may be. They are commutative groups. You can prove them groups. Identity भी है, inverse भी है, associativity भी है, and binary composition भी है. So Q star dot, here Q naught is Q star where 0 is not included. R naught is R star where 0 is not included. These are commutative groups. These are commutative groups. Here 1 is identity, 1 by A is inverse of A in each case. Yes, you can find out the element which आप किसी element को लो, A को लो, आप किससे multiply करोगे वापस A आ जाए 1 से. So 1 will be the identity, left identity भी 1 ही है and right identity भी 1 ही है. 1 into A भी A ही है और A into 1 भी 1 A ही है. और A का inverse क्या आ जाता है 1 by A, right? So A inverse is here is 1 by A. Because A into 1 by A is 1 and 1 by A into A is 1. So this is all easy. There is matrix example you can do on your own. It's very easy. It is forms a group and inverse of A is minus A. 0 is identity. Now, the main thing is what are Quaternarian groups. These groups play a very important role. Let us define set G as plus 1, minus 1, I minus I, J minus J and K minus K. I think you all are very familiar to these letters. Yes. So in vector calculus you have done these things. So what is the notation? What are the things that you should know particularly about this group that further you know in advanced stage that this group has all subgroups normal. You also know that this group is a non-abelian group. Yes, it's very easy to prove because if you take I into J is K, but J into I is minus K, right? So it is non-abelian group. So you can see the figure where red arrows represent multiplication on right by I and green arrows represent multiplication on right by J. So it's very easy. Vector calculus may you have done this. So this is quaternion. Now we have some other group which is Kleins 4 group, right? So this group is very important in the group theory. Yes, further you will know in advanced stage that this group is K4 के नाम से हम जानते हैं K4 and it will be isomorphic to Z2 cross Z2, right? You will know in advanced stage. So here G is EABC. Yes, here G is EABC with operation O defined by the following table. So which operation they have defined? You take 4 elements and here E is identity, A square is identity, B square is identity and C square is identity. So every element has a square is identity and precisely C is AB, basically AB is C. So you can do that and you can make it as group, which is uniqueness of identity. In the groups you follow that every identity is unique. Obviously there is only one identity in group. So let's suppose E and E dash are two identity elements. Yes, in a group G. This is group G, right? So E is an identity element, So E dash is E dash E is E dash, right? A is E, A is A. Yeah, I have talked about it in the first lecture that if you multiply identity with some element, then it reverts back the same element. E dash is an identity element. So again, E dash is E dash is E, and these statement prove that E is going to be same as E dash. You can see. So identity is unique in groups. Now द थ्योरम इज कैंसिलेशन लॉज. तो ये बहुत बेसिक्स चीज़ें हैं, ये पूरी कवर्ड होनी चाहिए. अगर आपकी ये चीज़ें कवर नहीं है दैन इट्स क्वाइट फॉल्ट. So yes, we should discuss cancellation laws. Suppose A, B, C are arbitrary elements of group G, then what happens is you take AB equal AC, then it must imply B is equal to C. तो A से A cancel हो गया, A से A, this A, then you will get B equal C, this thing. Then it is called left cancellation. And B equal C implies B equal C, it is called right cancellation. So what is the proof of it? Yes, तो जैसे कि E आइडेंटिटी एलिमेंट है ग्रुप में. yes, E is the identity and A B C आपने ग्रुप में से लिए, right? You take this one A B C and then AB is AC. yes, AB is AC. So because an inverse of A exist, because it is a group, so inverse जो है A का वो exist करेगा. तो inverse exist करेगा तो A inverse AB और A inverse AC से आप multiply कर सकते हैं, right? So EB is EC and associativity लगाई आपने तो B will be C. Then it's done. It's very easy cancellation laws. So now there is matrix multiplication also does not necessarily obey cancellation laws. If AB equal BC then and A is not equal to 0. Consider set of 2 cross 2 matrices with integer coefficients. Matrix multiplication is defined like this. So you know how matrices are multiplied. There is no way I can get you in. It's very easy how matrices are multiplied. एसोसिएटिविटी भी आप वेरीफाई कर सकते हैं. आइडेंटिटी भी सिंपल 2 क्रॉस 2 मैट्रिक्स है एंड ऑन. तो मैट्रिक्स मल्टीप्लिकेशन जो है वैसे तो मैट्रिक्स मल्टीप्लिकेशन कैंसिलेशन लॉ होल्ड नहीं करता. लेट्स दिस इज द एग्जांपल ऑफ इट. यू कैन सी दिस. या इट्स क्लियर. ए बी इज ए सी बट yes, A is not equal to yes, A is no, AB is AC but B is not equal to C here. These are random examples. There is another which is uniqueness of inverse. Uniqueness of inverse बहुत important है. Inverse of each element of a group is unique. So if possible let A and B be two elements of group G so that BA is AB's identity and CA is AC's identity. It is a definition of inverse. ये inverse की वो है properties. Inverse को ऐसे define करते हैं. A आइडेंटिटी है G की, तो B is E C A, तो B is C A and you know by cancellation laws what have proved that B is C. You can cancel A. Yeah. So again there is very important theorem. Yes. So we left identity is also the right identity. Yeah. Left identity जो है वो right identity भी कहलाती है, right? So let E be the left identity of a group G and let A belong to G be arbitrary, then EA is A. Suppose E is the left identity of the group, right? To prove E is also right identity, it suffices to show that AEA is A. AEA दिखा दिया तो done है. Suppose A inverse is left inverse of A, तो A inverse is the left inverse of A. Then A inverse A, what is this? A inverse A. Then it is identity. And by associative law, A inverse A is again A inverse of A E is equal to E. So A inverse A will be E. So A inverse A is again A by left cancellation laws. So it's I think very clear and so on. So A yes. So A is A. तो इससे क्या हो गया कि left identity is also the right identity. Reverse rule. So it is very important rule. Again I will say this because it's very important to discuss about the inverse of the product of two elements, right? So ये बहुत ज़रूरी है कि इन्वर्स अगर आप लेंगे ना, दो एलिमेंट्स लिया आपने, उनके प्रोडक्ट करा और उनका इन्वर्स लिया, और प्रोडक्ट मीन्स द ऑपरेशन इन द ऑफ द ग्रुप, then you take the inverse. then this inverse is B inverse A inverse. Okay, so consider arbitrary elements of a group G, and since B inverse and A inverse are inverse of A and B, तो B inverse B and B inverse C तो बहुत क्लियर है, तो इसमें कुछ है नहीं ऐसा. Hence by associative law से क्या कह सकते हैं, A B inverse A inverse. तो आपने क्या करना होता है कि ए बी इज आइडेंटिटी, तो हेयर ए इज ए बी एंड ये जनरल सिंबल्स हैं ए और बी, ये कोई पर्टिकुलरली ए बी नहीं है यहाँ पे. तो ए बी की मल्टीप्लाई मीन्स ऑपरेशन लगा दो आप बी इनवर्स ए इनवर्स से, दैन यू विल डेफिनेटली बाय एसोसिएटिविटी यू गेट आइडेंटिटी. So you can generalize this result also. Yes, for any n number of elements it holds. I think it's well clear. It was reverse rule. Now there is another theorem. Suppose G be a group and A belongs to G, then A inverse of inverse is A. If you talk about A inverse and you calculate the inverse of A inverse, then it is coming out to be A. So suppose I have provided the proofs in a very easy manner. Suppose A inverse be the inverse of element A of group G, then A inverse A is identity. To prove that A inverse of A inverse is A, then what you do is, क्या करना है आपको, फर्स्ट को आपको जो फर्स्ट इक्वेशन है दिस इक्वेशन को आपको मल्टीप्लाई करना है A इनवर्स ऑफ इनवर्स से, राइट. तो A इनवर्स ऑफ इनवर्स A इनवर्स A and you use associativity is A inverse identity, and so A inverse का inverse is EA is A, right. Again it is very clear. So and also there is a remark which is identity ka inverse is also identity. You can see this by this theorem, right. So I hope you have all cleared these concepts and gone through the lectures. So it was very easy definitions on the group theory, और ये सब basic ही है. So I am covering the basics only. And sorry for the late video I have shared to all of you, and because okay, so I will be updating you more and more on the next videos. So I will be covering the group theory basic. So let's enjoy the videos, and don't forget to subscribe the channel and hit the bell icon for the more updates, because I will be covering and sharing more important lectures and anything related to the competitive materials. You can see the bio of the channel. Thank you so much for your patience and attention towards the lecture. Thank you so much. And if you have any doubt, you can comment on the comment section box. Thank you.